Hey guys, today we're doing conditional probability and Venn diagrams. So I got a quick example here to help describe what's going on in a Venn diagram. We've obviously got our two circles, which represents the events or sets, and the square around it represents the universal set or the sample space. Where these two circles intersect, the intersection is where they're both occurring, A and B, and sometimes you'll see a bubble in one of the circles that indicates the total number of elements throughout it, okay, which we can write n bracket A is the number of elements in A. So it's a shorthand for how we say that. Now, Venn diagrams are useful for when we're modeling the intersection of two or more events. Okay, so I had a question the other day where they're like, why are we learning Venn diagrams? Now, when there's only two circles, a two-way table can be used, which I'll give an example a little bit later. But when there's three events or characteristics that are occurring, two-way table doesn't cut it anymore. So Venn diagrams are going to be the way that we're going to go. Let's give this a shot. So our first example is in a class of 24 students, 9 take physics, 11 take chemistry, and 4 take both physics and chemistry. Okay, so I've called physics P, chemistry C, and the intersection of P and C, or P and C if you'd like, is 4. So I've already got a Venn diagram set up. I've labeled it P and C so I know which set is which. The little bubble indicates the total number of elements within the whole circle. And I know 4 goes in that part because that is both physics and chemistry. So if 9 are in the entirety of this circle and we are in no part of it, the other part has to be 5. 5 and 4 make 9. Then with chemistry, we know that there's 11 people in total, and 4 of them take physics, which means 7 take only chemistry and not physics. Okay? It's not physics because it's outside of the physics bubble. And how many students have we accounted for so far? We've got 5 plus 4 is 9, plus 7 is 16, and we are talking about 24 students in total. So we're missing another 8 out here. When we add all of these together, we should get the total. So, double check, 9, 16, 24. Yeah, that works for me. So, after that, we're going to be asked questions about it. What is the probability of a student taking physics given that they're not in chemistry? So we're thinking about the people that are outside the chemistry bubble. How many people are outside the chemistry bubble? How many people are not taking physics? Remember that given condition makes the total that I'm talking about. There is 5 plus 8, 13 people not taking chemistry. Out of those 13, how many of these are also taking or are taking physics? And that's 5. Okay, so we're only talking about the 5 and the 8 of the 13 people outside of that bubble. 5 of them take physics. So, what is the probability of chemistry given that they are taking physics? How many people are taking physics? There's 9 people in that bubble there, as indicated by the bubble, or you can just do 5 plus 4. How many people are taking chemistry that are also taking physics is 4. So, this is supposed to be an afternoon, so I haven't written it quite there. The cursor out of the way, it's kind of annoying. Two-way tables can help when there's two characteristics, as I was mentioning before, and it looks a little bit like this. We have chemistry, not chemistry. You might see it with the line above instead. Okay, physics and not physics. And we can fill in 4 take both physics and chemistry, 24 in total, 11 take chemistry, 9 take physics. So how many people aren't taking physics is 15. How many people aren't taking chemistry is 13. How many people are taking chemistry but not physics? 7, 5, 8. We've done two-way tables before, so I don't want to spend too much time on it, but it can be useful to help organize your thinking. Because sometimes Venn diagrams are hard when you're trying to think of what's outside the circle, or when you need to. So, let's talk about another example here. We've got, get to the top of the page here, 30 puppies are at a school. Are taught 3 commands. They can do walk to heel, they can roll over, or they can stay. And we're given several bits of information about what is happening with these 30 puppies. Okay, we know 10 of them have learned to stay, 12 of them have learned to roll over, 2 can do all 3 of these, walk to heel, roll over, and stay. 7 can walk to heel and roll over, 5 can stay and roll over, 3 can walk to heel and stay, and 6 can do none. So if we're drawing our Venn diagram, what does this look like? I've done a rough sketch here. And what I'll do is I'll fill out a couple of these paths and then I'll let you try and finish the rest. So we've got 30 in total. That's a number that we want to remember. It's not on the screen at the moment, so I thought I'd write it in again. We know that 2 can stay and roll and walk to heel, so that is the intersection of all 3. Okay. 10 can stay, I've got this little bubble here, 12 can roll over, and 6 can do none. You want to try and place the easiest information on the page first, and then you can use that to help you answer the other parts. So, let's take a look at this next bit of information. 7 can walk to heel and roll over. So walk to heel and roll over is this part of my Venn diagram here. That's where walk to heel and roll over cross over. I know 7 is in that section altogether. I already know that 2 of them are there, so there's another 5 in the other part. Same can be said about stay and roll over. Stay and roll over is this part right here. 2 of them can do all 3, so if there's 5 in that section altogether, 3 has to be there. Why don't you take a second to pause the video, see if you can finish the diagram yourself, and in a moment I'll just remove the page. So, hopefully you've gotten the same numbers here. Okay, we'll double check that they all add up. 4 plus 3 plus 2 plus 1 makes 10, so the number that would stay correct. We've got 1, 2, and 5, 8, 15 that can walk. You might even put that little bubble in there to say that there's 15 that can walk to heel. And hopefully with that 7 that you may have done, or probably did last, you need to make sure that you use the total. You've gotten all the rest of the information. The 7 was the hardest because you had to add up everything and make sure that the 7, well, that what was missing added up to your 30. So, do a couple questions here. We've got probability to roll over and, or given that they walk to heel, sorry, not and. So how many can walk to heel? Well, it's indicated here, 15. Out of the 15 that can walk to heel, how many of them can also roll over? Roll over is that intersection there. So that's 7. So it's roll over and walk to heel. It's that top part. How many of our dogs have learnt to stay? That's 10. How many of them have learnt to stay and walk to heel? That should be walk, not wall. Walk to heel and stay is these 3 up here. So 3 out of 10 can do that. I mentioned using two-way tables before. It is harder to do, or I'm not sure how to do one, to be honest, when there are 3 characteristics like we've got above. Okay, that only really helps us when we've got our 2. Anytime you're doing these Venn diagrams, make sure you consider the complement or the not. So 13 are doing physics. Sorry, 9 are doing physics. How many people aren't doing physics is the 15. That kind of thing that we were talking about a little bit earlier. If you think about the complement, it's going to help you to figure out some of these Venn diagrams. Okay, well, I've written an example here. If 15 out of 27 people take neither art nor music, then the complement means that 12 take either art or music. So we've got our final example here. Got in a class of 27 students, 15 take neither art or music. Of the 6 who take music, 3 also study art. Okay, so we've got 27 students in total. 15 do not take art or music. So what's inside the circle should add up to 12. Of the 6 who take music, so there are 6 people in total that take music, 3 also study art, which means that 3 only study music. And then, because we mentioned that the 12 is what should add up to the total, or you could go 15 plus 3 plus 3 is 21. 6 take art but not music. So, a couple questions here. Remember that the bottom of each of these fractions is going to be our condition. How many people take music? There are 6. How many people take art and music? There are 3. What's the probability that they take art given that they do not take music? Okay, so how many people are outside of the music circle? There are 21 in total, 6 plus 15. How many of those 21 take art? Well, that's 6. It's this part. Probability that they do not take music given that they do not take art. Okay, how many of them are not taking art? So outside of this art circle, there are 18. Out of those 18, 15 don't take music. Hope that helps out, and let me know if you have any questions.